Alright, I'm going to start off with the second problem here for projectiles just in the y direction. Mr. Vitale, in his infinite coolness, throws Expo markers into the air and catches them sometimes. One time he threw one and it was in the air for 3 seconds before it returned to his hands in the same y position. How fast did he throw the marker initially? So again, I always like to start with drawing a picture. Notice I got some blue marker on my hand. But anyway, so we take, here's Mr. Vitale if you like. And he throws the marker. Here's the marker represented by a circle. I'm going to spread this out, but we know that it goes only up and down, not over to the right. But basically it comes up and then it comes back down like that. And it goes to the same Y position. So we'll call this 0 right there. The only thing that they really tell us is that the time that it takes is 3 seconds. So what we're going to do is we're going to set up our givens chart. However, this time we do not need to include the x direction because we know we're throwing it straight up and it's coming straight down. So there's no change in x or anything like that. So when you draw this, you're just going to say delta y, v initial, v final, acceleration, and time. We always know that acceleration is negative 9.8 meters per second squared. Time was given to us as 3 seconds, and that's for the entire trip up and down. V final, we're not sure. V initial is what we're looking for. How fast did Mr. Vitale throw this up? Delta y is kind of tricky. Delta y we normally think of as being a height, but delta y is really the displacement. If this ball goes up and then returns back down to the same y position, what is the delta y? 0. The reason for that is that it starts here, ends up here, so the displacement, or how far it's moved from its initial point, is 0. It hasn't moved really. And this is for the entire trip. Let me make that clear. You'll see why in a second. So now that we have 3 variables, we can solve for a fourth easily. We'll use our 3 equations. We have v final is equal to v initial plus at. V final squared is equal to v initial squared plus 2a delta x. And delta x is equal to v initial t plus 1/2 at squared. If we're given t and we have a and we have delta y, but we don't care about v final, we're going to use this one because this one doesn't have v final in it. So when I plug it in, remember we can change this to delta y if we'd like. Make sure everything's in the y direction. So we have 0, which would be delta y, is equal to v initial, which is what we're looking for, times the time, which is 3, plus 1/2 negative 9.8 times 3 squared. Notice I'm leaving out the units in this equation. We don't need to put them in for just now, but just remember when it comes out we should get a meters per second for the units. Anyway, so you just go ahead and do some math there. So it's just 1/2 times negative 9.8 times 3 squared, which is 9. You get negative 44.1 for this section here, and that's v initial times 3 still. And that's still all going to be equal to 0. So we're just going to bring this over. 44.1 positive now, right? Because we add it to both sides is equal to 3 times vi. I just rearranged that. And then we just divide both sides by 3 to get our final answer. So v initial is equal to 14.7 meters per second. And that's our final answer. There's actually a second way that we can solve this. Sometimes we need to utilize this way if we're not given certain pieces of information. So I'll show it to you. I think it's useful and it might prove useful later. But for right now, this is probably the easiest way to solve this problem. If you look at, I'll redraw it for you. Again, remember this is just going straight up and down, but I'm going to spread it out across this x-axis here so we can just see it go up and down. If it goes just straight up and down like this, the time that it takes to complete the whole entire thing is 3 seconds. The time that it takes to get to its max height ends up just being half. This is only true for perfectly symmetrical parabola, trajectories. If you were throwing an object off a cliff, this wouldn't be the case because you would have a max height and then this would just keep going and going and going, and therefore this side would take longer than this side. But if you're looking at an object that has just a perfect trajectory like that, you can make this assumption. So that if this is 3 seconds to go from here, then this would just be 1.5 seconds. So if we want to rewrite this, you could say that the time would be half to get to the half. So we're actually just looking at the half here. So 1.5 seconds to get to the max height. The max height now is going to be something that we're not sure of. Before, we knew that it was 0 if you come up here because we knew that it just came back to the same spot. This here, we were not given how high it went. We're also not sure of the v initial. However, there is one new piece of information that we can plug in that we didn't have for the whole entire trip. That is that at the max height, the object comes to a stop. We know this because it's changing directions. We could look at a motion map for it, right? If it has an initial here, or not a motion map, a velocity versus time graph. If we throw it up with an initial velocity, it's going to do something like this because we know that it's accelerating negatively at -9.8, right, for acceleration versus time. At this point here, it's 0 meters per second, and we know it has to be in order for this to be continuous. So if it's 0 meters per second at the top here, we can plug that in for the final velocity. So what we're essentially doing is just looking at this piece. We're not worried about this half. So we're saying, what is the v initial for this thing to go in 1.5 seconds up to its max height and stop? That's what we're asking, really. We know that this is negative 9.8 like usual, and so therefore now you have these 3 givens, and then you can solve for the v initial that way. Hopefully you would still get 14.7 meters per second. I think in this case you would use the one that doesn't have delta y in it because you don't care. So then it would be v final is equal to v initial plus at. So v final is 0. V initial is, we're not sure yet. Acceleration is negative 9.8 and time is 1.5. Negative 9.8 times 1.5 is, well, what do you know? It's negative 14.7, and then when you add it onto this side, you're going to get v initial is equal to 14.7 meters per second. So either way gives you the same answer, which is pretty cool, I think.